Okay, today we'll deal with negative exponents. Okay, before we get started, take a look at this pattern. Ten to the fourth, to the third, to the second, 10 to the first, and now we have 10 to the 0 power. So how much is 10 to the 0 power? Look at the pattern. The answer is just 1. 10 to the 0 power is 1. Matter of fact, anything to the 0 power is 1. By the way, also to let you know that on our paper today, we may be using 2 pieces of paper, or the back side of your paper. All right, 3 to the 0 power is 1. Anything to the 0 power is 1. If I have the letter A to the 0, A to the 0 power is 1. If I have a problem such as 2, A to the 0, how much does that equal to? 2 times A to the 0. A to the 0 is 1. So I have 2 times 1, and 2 times 1 is 2. So see that? Anything to the 0 power is 1. Doesn't matter if it's a variable or a number. Okay, our title is negative exponents, so we're going to lead up to that point. Okay, we're going to do the same problem 2 ways. So I just kind of stacked them on top of each other. So on the top here, this is what we're used to doing. We have 4 A's on top, 2 on the bottom, and we can see that these will reduce. And so what are we left with? We're left with just A, and then we have 2 of them, so it's A squared. So basically all we did was just, we had 4 A's, take away 2 A's, and that gives us 2 left over. So notice we could have just subtracted the exponents. We could have just said this is 4 A to the 4 minus 2, right? 4 minus 2, 4 minus 2. And that gives us A squared. So see the same answer. We end up with the same answer. So again, these 2 answers were the same. All right, we're going to do 2 more examples. Just to the right there. And so we have A to the 3rd over A to the 5th. We'll do it twice. So on top here I have 3 A's. And on the bottom I have 5 of them. And if I reduce, okay, what do I end up with on top? On top that's 1. And on the bottom that's A to the, that's 1 over A squared. Excuse me. Now in the next example, we're just going to go ahead and subtract. So this is going to be A to the 3 minus 5. Right? 3 minus 5. Just like we did on this other example, 4 minus 2. Three minus 5 is negative 2. So wait a minute. So we have this answer and then the different answer for the same problem. Right? And now we're ending up with negative exponents. So we have the same problems, we get the same answer, or different answers. So we're saying that this answer, A to the negative 2, is equal to 1 over A to the positive 2. And it turns out that, yeah, these are equal. They are the same. It's just another way of writing the same value. Now, if it helps, you could just imagine that there's a 1 right here, 1a to the negative 2, and then you can imagine there's a little fraction bar there. So what happens is, if I cross this bar, this negative 2, if I cross it, it becomes a positive 2. So the negative 2 becomes a positive 2, just the exponent itself. So what we're saying is that anything that's negative is in the wrong location. The location's wrong. That's why it's negative. If I bring it down here, now it's positive. Now what we'll do is we'll do 4 examples where we're going to change them to positive exponents. So if there's any negative, change them to a positive exponent. Okay, here's our first example. We want to change it so it's positive exponents. Well, let's see. The 2 there, that's fine. The exponent's actually a positive 1. The x squared, well, that's positive, so that stays alone. And then, wait a minute, this is negative. So you're going to have to cross that bar. It's in the wrong location. So if I bring it above the bar, it becomes a positive 3. So it was negative 3, then I cross the bar, now it's a positive 3. And that is your answer. That is it. Okay, in our second example, we have 2 of them that have negative exponents. So those are the ones we want to move. So, first of all, I3 can stay alone, stay by itself. The A, I'll kind of go alphabetically. The numbers, then the letters. So 3, that can stay down there, at the bottom. A, that has a negative exponent, so let's bring this down. We'll cross this bar here. So now it's a positive 2. It was negative 2. I cross it. Now it's positive 2. The B, well, that's already positive, so that stays alone. Stays by itself. Or does not change. Okay, C. Hey, that's okay. That's a positive exponent, so I'll leave that where it's at. It's in the right location. D, that's a negative. It's in the wrong location, so I'm going to have to move it up. So I'll move it up here. And when I move it up, it's not negative anymore. It's positive. See, it was in the wrong location. This one was in the wrong location. Now everything is where it should be.